All right, let's dive right in. We're going to tackle a puzzle, a mystery, really, that had humanity stumped for more than 2,000 years. It all started with just looking up at the night sky. And, solving it didn't just change our map of the solar system, it unlocked the entire universe. So let's get into it.
So where are we getting all this from? Well, our guide for this little journey is this absolute beast of a book, An Introduction to Modern Astrophysics. You might know it by its nickname among students, the Big Orange Book, or just BOB. It's pretty much the definitive text on the subject. We're going to break down one of its most fundamental stories.
And yeah, that story kicks off with a really simple question. For thousands of years, we've looked up at the night sky and just wondered, what is actually going on up there? How do we make any sense of all that movement? This was, no joke, the single greatest detective story of ancient science.
Okay, so our story begins, and you've probably heard this before, with the ancient Greeks. These guys were, they were meticulous observers, and they noticed something really fundamental about the night sky that kicked off a 2,000-year-long search for answers.
What they saw was that, the vast majority of stars, they were totally fixed in these patterns, the constellations, that just wheeled across the sky, super predictably, night after night. But then there were these other lights, just a handful of them, that refused to play by the rules. They would actually drift against that fixed backdrop. The Greeks gave them a name for this, planetes, which means wanderers.
And this is the part that was so weird, the thing that made these wanderers so baffling. Most of the time, they'd drift slowly to the east, but then all of a sudden, they would slow down, stop, and start moving backward, to the west, for a few weeks, maybe a few months, before turning around and getting back on track. This bizarre backward dance is called retrograde motion.
And look, I really can't overstate this. Explaining retrograde motion was the central problem in astronomy for nearly 2 millennia. It was a complete head-scratcher. Any theory about the cosmos had to explain this bizarre little loop-de-loop. So what was the first big idea?
So the first big attempt to solve this, it was logical, it was intuitive, and, as it turns out, it was completely wrong. It was this idea that, everything revolves around us.
The Greeks, guys like Plato, they proposed what we now call a geocentric or Earth-centered model. And honestly, it makes a ton of sense, right? We don't feel like we're moving, and every day we see the sun, the moon, and all the stars circle around us. Plus, they figured if the Earth were really zipping through space, we should see the nearby stars seem to shift against the really distant ones. That's a thing called parallax. They looked for it, and they saw nothing. So conclusion, the Earth had to be stationary. They pictured the stars as being sort of tacked onto this giant celestial sphere that rotated around us. Simple, elegant, and, flawed.
But here's the massive problem with that beautiful, simple idea. A spinning sphere works perfectly for all those fixed stars, but it just completely falls apart when you try to explain those wandering planets and their strange retrograde motion. If a planet is stuck on a sphere that's just spinning smoothly, why in the world would it ever decide to move backward?
So, to save this Earth is the center of everything idea, astronomers had to get, let's just say, creative. They basically invented a fix, circles on top of circles. They said, okay, a planet doesn't orbit the Earth directly, instead it moves on this little mini-circle called an epicycle, and that little circle is what gets carried along the main orbit. It was a clever patch, for sure, but it was just the start of all the complications.
And this quote from the book just illustrates the problem perfectly. It says, when a disagreement between the model and observations would develop, the model was modified slightly by the addition of another circle. Can you imagine? For centuries, every time the model broke, the solution was just, let's just bolt on another circle. The whole thing became this incredibly complex, clunky machine that lost all of its original elegance. And then, after centuries of this patched-up model, the 16th century rolls around, and with it comes one of the biggest aha moments in human history. A total game changer that didn't just add another circle, but redrew the entire map.
So this guy right here, this is Nicolaus Copernicus, a Polish astronomer who, after decades, literally decades, of painstaking work, dared to suggest something absolutely wild. He looked at this ridiculously complicated system of circles on circles and just thought, there has to be a better way. So he asked, what if we've had it all backward this whole time? What if the Earth isn't the fixed center of everything, but just another planet? And what if all the planets, including our own, are actually orbiting the sun? This was the heliocentric or sun-centered model, and it changed everything.
And this is the absolute genius of it. That 2,000-year-old puzzle of retrograde motion, it didn't need a super complicated machine to solve it. Turns out it was just an illusion. It's all about perspective. Think about it like this. You're in a car on the highway, and you're about to pass a slower car. As you go by, for just a moment, that other car looks like it's moving backward against the trees in the distance. That is exactly what Copernicus realized was happening in the sky. Our faster-moving Earth on its inside track simply laps a slower outer planet like Mars, making it look like it's moving backward for a little while.
And boom, just like that, the biggest, most complicated problem in astronomy just, poof, it was gone. It didn't need a fix, it didn't need more gears or more circles. All it needed was a totally new point of view. This shift wasn't just a better model, it was a cleaner, simpler, and way more elegant explanation of how things really are.
But here's the thing. The Copernican revolution, it wasn't just about solving some old riddle. It was the moment that astronomy started leveling up and becoming astrophysics.
See, once we finally got our heads around the idea that Earth isn't special, that it's just another planet playing by the same rules as everyone else, well, we could start applying the laws of physics to the heavens. We stopped just describing how things moved and started asking the really big question, why? That's the birth of modern astrophysics, right there.
And that one single shift in perspective, man, it just opened the floodgates. Solving that one puzzle of how planets move unlocked literally everything else. Suddenly, we could ask these huge questions that created entire new fields of study. The nature of stars, what are they made of? Stellar evolution, how are they born and how do they die? Black holes, the absolute limits of gravity. Galactic evolution, how do trillions of stars build these cosmic cities? And cosmology, the study of the entire universe itself, from its very first second to its ultimate fate. All of it stands on the shoulders of that one critical shift.
Which kind of brings us to this beautiful, almost haunting quote, after all of this discovery, after centuries of unlocking cosmic secrets, we're left with the most profound wonder of all, that any of this exists in the first place, and that we, on our little wandering rock, can actually begin to understand it.
From that first puzzle of retrograde motion to the mysteries we're tackling today like dark matter and dark energy, there are always new puzzles waiting out there in the cosmos. So it makes you wonder, what's the next great cosmic mystery that you think we're on the verge of solving? Thanks for joining me on this one, and seriously, keep looking up.